Okay, total area under the normal curve, guys. What's the answer? We should know that from chapter 5. Always the total area under the curve is what? Any response?
1.
100%. Yeah. Next question. See, how long does it take to answer this question? It shouldn't take long. It's just few seconds and you can move on to the next question. Next one. All right, clear. Could the graph represent a variable with a normal distribution? Well, yeah, it looks like it is a bell. If you zoom in here, guys, you can see it, just clear. Yes, it does. It has tails. I mean, they look like they're touching. They're not supposed to touch, but they didn't mean, just that for them, to touch. So it looks like a normal bell-shaped curve. So the answer will be yes for this one. Find the area of the shaded region under the standard normal curve if convenient, use technology. So we want the area between -2.46 and 0. So let me get the calculator ready for you guys. And now we're going to go back and review chapter 5. So turn it on. And you go to second, variables, normal CDF. Okay, lower, guys, it's -2.46, if I'm not mistaken here, -2.46. Upper is 0, and then 0, 1. When you do Z, it's always 0, 1. And you can see here, he put Z. Can you see the Z on the right? And that's just hit paste, and you can get the probability. This is chapter 5, guys. So the answer is 0.4931 if it is to 4 decimal places. Next, find this area here. Again, let me bring the calculator up. Second, clear. Second, variables, normal CDF. Okay, guys, can you tell me what's the lower here? What's the lower limit?
-1.56.
No, the lower is the lower value.
Oh,
Right here. Negative what? Million?
Yeah.
And then -1.56. And then 0, 1. There you go. It's 0.0593. Next question. Area, assume the random variable is normally distributed with mean is 50 and standard deviation is 7. So it's not 0, 1 anymore, it's X. So mean is 50 and find the indicated probability greater than 36. Let me bring the calculator, guys. So second, normal CDF. Okay, what would be the lower? We need to go from 36 and up. So
36 would be lower.
36 will be the lower limit. And what's the upper? The sky is the limit. And then the mean, guys, don't keep 0, 1. He says the mean is 50 and the standard deviation is 7. And here you go. 0.9772. That's the answer. Next question. In a recent year, this is just like your chapter 5 assignments, guys. Just exactly like an assignment. The total score for a standardized test were normally distributed with a mean of 500 and standard deviation of 10.4. Okay. What's the probability that the randomly selected medical students who took the test had a score of less than 485? So let me bring the calculator. Second, distribute, normal CDF. We don't use PDF, it's only CDF. Okay, less than 485. So you guys agree with me, when it is less, you start with -1 million. Oops, I put 2 signs here. -1 million. Then enter, then 485. Then the mean, 500. Then the standard deviation, which is 10.4. and then paste. There you go. That's the probability. Find the probability the randomly selected medical students who took the test has a score between 499 and 514. That should be very easy in between, guys. I can assure you're going to have a question like this in 3 parts. So be prepared to answer this question. So between 499 and 514, you just put 499, 514, and then leave the mean and the standard deviation are the same. And here's the answer, 0.4491. So we did greater than, between, now it's going to be probably less than, or more than, sorry. We did less than, now it's going to be more than 530. Okay, so how do you do more than 530? Can a student tell me here? Oops, sorry, clear, second, variable, normal CDF. Okay, more than 530. So what would be the lower bound?
530.
530, that's correct. I hope that this is ringing a bell, guys. I'll be nervous if you tell me no, you forgot it. And then mean, standard deviation, and here you go. That's the answer, 0.00195. It will be 0.002 if you round it to 4 decimal places. Are any of the events unusual? Well, actually, yeah, this one is less than 5%. So the last one is unusual because it is less than 5%. So you say event in part C is unusual because the probability is less than 5%. Let me clear this and take it to the next question. 7. Use the standard normal table or technology to find the z-score that corresponds to the following area. So now you have the area and you need to find the z-score, and you guys remember it's inverse norm. So when that comes to this, it has to be, let me just, inverse norm. So it's going to be I don't know why. I apologize. It's just annotation, you know, just in Zoom hasn't been working for me. So it will be inverse norm. Let me just go to the calculator right away. He gives you the area and he wants Z. So you just go second and variables. And it's next one, guys, number 3. We need the area to the left. The area to the left, it's a cumulative area, which is 0.9412. And then 0.1 because it's a z-score. So, and then you get the answer. There you go. So it's 1.56. Okay, any questions here? So you just enter 1.56 right here, and then that will be the correct answer. And move on to the next question. The per capita energy consumption level in kilowatt hours in a certain county for a recent year can be approximated by this distribution. The mean is 2,325 and the standard deviation 592.6. What consumption level represents the 7th percentile? 7th percentile means 7%. That means the area to the left, guys, is 7%. To do this one, you just go to your calculator and do the exactly same thing as we did in the previous exercise, inverse norm, but you put 7% here. 0.07. And then the mean is given here, 2325. So it's not the Z, it's an X value. And 592.6. Paste. 1450.44. What did he say? Round to the nearest integer. So will be 1,450. For the next one, what consumption represents a 16th percentile? Guys, it's exactly the same thing, but instead of 7%, you just use 16. Please go back and redo those problems. You need help, watch this video, watch it at the places where you need help with. You can move it forward. So that's the answer. It will be 1,736 because if you round it up to the nearest integer, it will be 1,736. What consumption level represents the third quartile? Who can tell me what the third quartile means as a percent? Yes? What is the third quartile as a percent? 3/4. If you change 3/4, guys, to percent, it will be 0. What? 75. Yeah. And then same thing. It has to be above the mean now because we're more than 50%. So that's the answer will be 2,725. Okay, so that's the answer to this question. We're wrapping up chapter 5. I think there's one more question. Okay. The graph of the waiting time in seconds at the red light is shown below on the left with its mean and standard deviation. Assume that the sample size of 100 is drawn from the population. Decide which of the graphs labeled A to C, so you have A, B, C, would most closely resembles the sample and distribution of the sample mean. Remember the applet when we did the central limit theorem. If you have a population that has a mean and a standard deviation, the distribution of the samples will have the same mean, but their standard deviation will be a lot less. It will be sigma over square root of n. So this is your original population, guys, right here. You have a mean of 18.5. Well, all of them have a mean of 18.5, but I can rule out one answer right away from those three, guys. Which one cannot be the sample and distribution? What do you notice about the three? Is it bell-shaped? Right here, C. It's not bell-shaped. Well, we know the sample and distribution must be bell-shaped. So it's between A and B. What's the standard deviation of A? 12.7. It is the same. It can't be the same. It has to be 12.7 divided by square root of n, which is square root of 100. So if you guys take 12.7 and divide it by square root of 100, what would you get? You get 1.27. You agree with me? So it must be B as the correct answer. Yep. So so if you choose the answers, here's how you choose them, guys. Graph B most closely resemble the sample and distribute because mu of x bar is the same, which is 18.5. It has to be the same mean, the central limit theorem. And the standard deviation equal 1.27. And the graph approximate a normal curve. It has to be normal. This one C is not normal, guys, so you cannot use it. And anyway, look at the standard deviation. It's the same as the original. It can't be the same as the original. It has to be a lot less. Okay, the height of fully grown trees of a specific species are normally distributed with a mean of 77 feet and a standard deviation of 6.5 feet. Random samples of size 11 are drawn from the population. So n is 11, remember that. Use the central limit theorem to find the mean and the standard error of the mean. So mu of x bar, guys, will be the same as the original mean. And the standard deviation will be the original one, which is 6.5. But you must divide it by square root of 11. But don't leave it like this for the answer. He wants the answer. You just do the math and get the answer. And 6.5 divided by square root of 11 is, let's see. .5 divided by, there is a square root, guys. 11. So I got 1.959. Let's see how many decimals he wants. 2 decimal places. So that should be, guys, 1.96. Now choose the correct graph. So we need to choose a graph that has a mean of 77 and a standard deviation of about 1.96, about 0.2. Well, it can't be B, guys, because it starts with zeros. It could be C, it could be A, 77, but look at this one also, 77. Okay, the standard deviation, guys, is 2. You know the curve can go 3 standard deviation to the right and 3 standard deviation to the left. So if you do 77 and add 2 should take you to about 83. But look what I have here. I have 90, so that can't be the correct answer. So it must be this one, guys, right here. That should take me close to 83 right here. So it's C. And if that's the answer to the question. But make sure here to put the answer, otherwise the system will probably not accept that fraction. Find the probability and interpret the results if convenient, use technology. The population mean annual salary for environmental compliance specialists is about 63,500. A random sample of 39 specialists is drawn from this population. What's the probability that the mean salary of the sample is less than 61,000? So when you write this one, let me try to annotate here, or probably just do a text here. So you start with probability of X bar, guys. When I put bar means there is a line above X equals normal CDF. Okay, lower than 61,000. So you guys agree with me? It's negative $1 million for the lower bound, then 61,000 for the upper bound. Then the mean is given to be 63,500, comma. And can someone tell me what's going to go toward the last? Would I just put 6,200 or I have to take 6,200 and do what? Because this is the probability of the mean, not the probability of one value. It's a probability of the mean. So you take 6,200 and you divide it by what? Square root of 39.
The square root of 39.
Yeah. That's exactly what you should do, guys. And then to do it on the calculator, it's very straightforward. Let me show you. I'll bring the calculator back. Clear. Second, variables, normal CDF. Normal CDF right here. You can do it in one shot. So negative $1 million. Upper is 61,000. Mean is 63,500. So guys, every time the question is about the probability of the mean, look, it says find the probability for the mean set that the mean salary, you have to use sigma over square root of n. So it would be 6,200 divided by square root of 39 and paste. There you go. And that's the answer, 0.0059. If you change it to percent, it will be about 0.59%. And you choose the correct answer. So about 0.59% of sample of 39 will have a mean salary less. Is this an unusual event? It is an unusual event, so it must be A because it's an unusual event. Any probability answer, guys, that is less than 5% is unusual. That will be your answer. Okay. Find the margin of error for the given value. So now we're
I'm sorry, the last one that you just did, you said it's unusual if it's less than 5%. Wasn't that more than, it was 5 something?
If it is more than 5%, it's usual. He'll always ask you for unusual events. So if your answer is less than 5%, you just say it's unusual.
Okay.
Find the margin of error for the given value. So he gives you C sigma n. Okay. The margin of error formula, guys. Let me just use text here. Unfortunately, I'm not having good luck with writing. So E, the formula, guys, it's ZC sigma over square root of n. Okay. Do you guys know what ZC at the 95%? You should memorize this one. I told you guys that's popular. What is this value, guys? 1 point what? 96. Yeah. You will have the table. You can use it. Times sigma, which is 3.3, divided by square root of 64. Let me just move, and that's it. So if I do the math, let me just bring the calculator back, just on the screen. $1.96, guys, times 3.3 divided by square root of 64, which is 8. Enter. And that would be the answer. He wants the answer rounded to 3 decimal places, so it would be 0.809. All right. So let me clear all drawing here. Next question. Use the confidence interval to find the, if you have the confidence interval, guys, and you ask to find the margin of error, that should be very easy. You subtract 0.192 from 0.310 and divide by 2. So what would be the answer? Let me show you on the calculator. So it will be 0.310 minus 0.192 and then divide by 2. The margin of error will be 0.059. How do you find the sample mean? You add up and divide by 2. The sample mean is the value in the middle. So it will be 0.192 plus 0.310. Make sure to do equal first and then divide by 2. And here you go, 0.251. Let me see. Okay. Next question, guys. Find the minimum sample size needed to estimate mean for the given values C, sigma, and E. Here's the formula for N. I will provide you with those formulas. ZC sigma over E raised to the second power. Okay, what's ZC at 95, guys? Yes?
1.96.
1.96. Let's do it right here on the calculator right away. Just move the calculator a little bit. Oh, what happened here? 1 second, please. Let me bring this back. Okay, we're back. So 1.96 times sigma, which is 9.8 or 9.6, I'm sorry. divided by 2.
No,
Okay.
you put 9.8, it's 9.6.
Oh, let's do it again. So 1.96 times 9.6 equal divided by 2 and square it. You have to round up, guys. Remember what I said about this. Even if you get 88.1, you have to round it up to the next whole number. So that will be 89 here. Your answer here, guys, you just type 89 and it will be accepted. 88 will not be a correct answer. So clear all drawings and move on. You are given the sample mean and the population standard deviation. Okay. If I give you the sample mean and the population standard deviation, what do we use? Z interval or T interval, guys? Remember, population standard deviation is given here, not sample standard deviation. So what is it, Z or T?
T.
T.
You guys,
Oh, darn.
this is a population standard deviation. We never use T when sigma is given. We use Z interval, just like in chapter 7. You're still confused. You need to do some review. Make sure to do some review with this one. It's going to be a Z interval. Population standard deviation. Take a note, guys. It's linked to Z. No
So
population
population
standard.
is Z and sample is T.
Exactly. When he gives you S, it's T. When he gives you sigma, it is, look here. Look, guys. Assume the population standard deviation. Once you see this word right here, now it is Z. If I don't say assume population standard deviation, be sure it's T. Remember what I said here. That's very, very important. And now to do the math, we'll just bring the calculator back and show you. Once you know what to do, guys, it's very easy. You go to stat, tests, and Z interval. Okay, I don't have data here. So he gives me, what did he give me here? He says random sample of 39, the mean closing price is 118.06 and sigma is 10.74. So 10.74. X bar is 118.06. N is 39. And confidence level, first time he wants 90. And here you go. You put the confidence level, 190, 15.23, 120.89. Then you go back and do it with 95. So just change this to 95, guys. And you get the answer. And which interval is wider? Always the one that has more confidence level is always the wider one. So it's a 95. Interpret the results. You can be 95 and 90% confident the population of stock is outside, not outside the bounds, it's inside the bounds. So we need 90 and 95. Let's see which one is going to be the correct answer here. You can be not certain, never certain. So you can be 90% confident that the population mean price of the stock is between the bounds of the 90% confidence interval, and 95% confident for the 95% interval. Yeah, that makes sense. So C will be the correct answer. Next. A publisher wants to estimate the mean length of time in minutes for adults spent reading. To determine the estimate, the publisher takes a random sample of 15 people and obtain the results below. From past study, the publisher assumes What does it say here, guys? Do you guys agree with me? It gives us sigma here. You see the sigma is 2.3. So what interval do we use here? Say it. Don't be afraid. If sigma is given, what is it gonna be? Z or T?
T.
I still see half confusion, guys. It's a Z test. Why? Let me pause here and see why people are confused about. So for this one, find the critical value TC for the confidence level. Z is 0.98 and sample size N is 25. So 98 and 25, guys, you have to do degrees of freedom. So 24, look right here. So it is 2.492. That's it. Done. Construct the indicated confidence interval for population mean using what? T distribution. Now it's a clear T, but let me show you why he says T. What does it say here, guys, where the mouse is pointing to? Read it for me, please.
S.
It doesn't say sigma. When it says S, then it is a T. Just take those notes, have them handy in front of you, so then you won't make that mistake of mixing this up. So it's going to be a T interval. Very straightforward, guys. Watch. Stat. T interval, not T test. T test, it comes in chapter 7. Okay, stats. We don't have a data, so X bar, guys, is 12.2. S is 2. N is 6. We usually, when the sample is small, we use a T at interval, actually, and then 95. And here you go. So your interval is 10.1. How many decimals? It says 1 decimal place. So it's 10.1 and 14.3. That will be your interval. Let's move on to the next question. In a random sample of 8 people, the mean driving distance to work was 25.9 miles, and the standard deviation was 6.3. He didn't say population standard deviation, so that's S, guys. Unless if you see the word population standard deviation, you assume it is S, not sigma. Assume that the population is normally distributed and use the T distribution to find the margin of error and construct a 95%. He gave you the hand, guys. He says use the T distribution. So it's just T interval. Let me go to T interval and answer the question. It's a very, very important question here. So clear. Stat, tests, T interval. And we'll answer all the questions once we get the calculator output. So what's X bar, guys, is 25.9. S is 6.3. Watch carefully here. N is 8 people. It says in a random sample of 8. Usually when the sample size is small, it's T. And he wants 95. Okay. So right here, guys, it's going to be 20 point, how many decimals he wants? 1 decimal. So it's going to be 20.6, 31.2. 20.6, 31.2. How do you find the margin of error? From the interval. I did the interval already. How would you find the margin of error?
So wouldn't you subtract?
Yeah, subtract and then divide by 2. You can use the formula. There is a formula for the margin of error, but I'm trying to make it easier on you guys. Find the interval and go back and do the margin of error. So it will be 31. Oh, I forgot what was it. Let me just go back. I'll get the results again and T interval. There you go. Okay, so 31.2 minus 20.6. 31. 1, 2. Oops. 31. 1, 2 minus 20.6. And what do I do now, guys? We're not done yet. You have to divide by what? By what? By 2.
2.
Yeah. There you go. 5.3. That's your margin of error. And he wants the unit. It's in miles because you're doing miles here. So in miles. All right. Interpret the results. Select the correct choice below. With 95% confidence, we can be said that the population mean driver distance to work is between the interval endpoints. So that would be the correct answer. And put 95. It doesn't make you write them down again. He says the endpoints. That's good enough. The D is wrong. It says it can be said that most driving distances. I told you guys, it's with 95% confidence, the population mean is between this and that. That's the language that you have to select always. All right, let's do the next one. The state test score for 12 randomly selected high school scores are shown on the right. Compute parts A through C below. Assume that the population is normally distributed. I don't want you to get confused when it says population is normally distributed, it means that sigma. All populations are normally distributed. It's when it says population standard deviation, you use Z. So guys, look here. He says, find the sample mean, find the sample. So he's given you the hint, it's S, so it must be a T interval. You can put those values into your calculator and find S and T, or you can use a static crunch. Let me show you how to use a static crunch to do this. And he says he wants a 99% confidence interval. So open in static crunch, watch. Since you did the project earlier, you should know how to find the mean and the standard deviation. Here's how you find the mean and standard deviation. You go to stat, summary statistics, columns, select. Okay, and let's hit compute. And guys, look, this is the mean 910.25. And the standard deviation is 305 point. How many decimals? He says 1 decimal place. So your mean is 910.25 and your standard deviation is 305.0. Okay. We answer this part. 99% interval. Look, you go to stat. And okay, guys, what do I use, Z or T? Can someone answer this one?
T.
Yeah, it is T. One sample with data. He gave me the data. Variable 1, look here and choose the level. 99%. That's it. Compute. Oh, I didn't put 0.99. Didn't take it. Here you go. Your interval bounds are 636.78, 1183.7166, and you round it to 1 decimal place. So it will be 636.8, 1183.7. How would you use this one using the calculator? Look what you have to do, guys. So let me just close this, bring the calculator up. You have to enter the data, first of all. I'm not going to do it, but I'm just going to show you how to get it started. Just put the data, start 1, 4, 2, 8, etc. Put the other values, 696, all of them. To answer the first part, look what you do, guys. You go to stat, calc, one variable statistics, and just calculate. it will give you X bar, and it will give you S, which is the standard deviation. These are not accurate, guys, because I didn't put the entire data set. Then when you do the interval, you go to stat, tests, T interval, and then data, because I have data sets, L1, and then just change this one to 99 and hit calculate, and you should get the interval. A gas mileage in miles per gallon of 25 randomly selected sports cars are listed in the accompanying table. Assume the mileage are not normally distributed. Use the standard normal distribution or the T distribution to construct a 90% confidence interval for population mean. Justify your decision. If neither distribution can be used, explain why. Well, since, guys, we have a random sample of 25 and the original, it's less than 30, and the original population is not normally distributed, we cannot use neither one. So you cannot do this problem. So what do we say here? Neither distribution can be used since the sample size, where it says sigma is unknown and n is less than 30, right here. Okay, so you have to have a population that's normally distributed if the sample size is less than 30. He has to mention that. Okay, next one. Which distribution? Okay, use the standard normal distribution or the T distribution to construct a 99% confidence. Justify your decision. Explain why. Oh, it's another one. In a recent, okay, what's the sample size here? 1, 2, 3, 4, 5. The population standard deviation of the yards per carry, all of the running backs was 1.39. The yards per carry of 25 randomly selected running backs are shown below. Assume the yards per carry are normally distributed. Again, guys, if the sample size is less than 30 and the population is not normally distributed, we will not be able to use Z interval or T interval to find the confidence intervals. Anyway, I won't be asking you questions that don't work. All the questions that I'm going to give you guys, that you will be able to construct confidence intervals. Okay. In a survey of 2,032 adults in a recent year, 1,270 say that they have made a New Year's resolution. Construct a 90 and 95% confidence interval for the population proportion. Do you still remember, guys, the name of the test? If I show it to you, now we're doing confidence interval for the proportion. Stat. Oops, sorry. Stat. Let me see, I got an answer in the chat. Not one prop Z test. It's not a test, it's an interval. So one prop what? Z interval. One thing I like to mention here, guys, don't mix up chapter 6 and 7. Chapter 6 about intervals, chapter 7 is about tests. So when you pick the formula, if it is a confidence interval, make sure it says interval in it. If it is a chapter 7, it will say test in it. And look here, it says one prop Z interval. So X will be, otherwise you will be wondering, just missing details you can't find because you picked the wrong test. N is 2032. And then confidence level is 90. Calculate, and here's the interval. And with the given confidence interval, it can be said with that the population proportion of adults, it's all about the population proportion of adults who say that they have made a New Year's resolution is between the endpoints of the given interval. And you do the same thing, guys, for 95%. always the 95% is wider than the 90% interval. Definitely. Okay, we got a couple more questions here. I already have the recording for chapter 7 questions, guys, so they will be there for you to view. Because this sample test I've done before, so I already have the recording for. We're not going to get to chapter 7, but I have the recording of the workout of the answers. In a survey of 2,761 adults, 1464 say that they have started paying bills online last year. Find a 99% confidence interval. That should be a very easy question, guys. So again, you go to stat. Don't pick the z-test, it's z-interval. So proportion interval. Not the proportion z-test. Interval. Right here, letter A. So the lower number is 1464. The upper number is 2761. And then the confidence level, guys, is 99. And here you go. So a 99% confidence interval population proportion is 0.5. How many decimals? He wants 3. It will be 0.506 and 0.555. How do you interpret the results? With 99% confidence, it can be said that the population proportion of adults who start paying bills is between the endpoints of the interval. So it must be this. Why not C? It says sample proportion. This is all about population proportion. So it's A. Next. Last one, I think. A researcher wishes to estimate with 99% confidence the population proportion for adults who support labeling legislation for genetically modified organisms. Her estimate must be accurate within 4%. So the 4% is the margin of error, guys. That's E of the true proportion. No preliminary estimates is available. Find the minimum sample size needed. This is the formula for the sample size, guys. N is P hat, Q hat. And then if you remember, it's ZC. I'll give you the formula. You don't have to memorize the formulas. Squared. Okay, guys, if you don't have an estimate of the sample proportion, what do we use for P hat and Q hat? Do you still remember the numbers that we use for P hat and Q hat?
0.05?
0.5.
Oh, just 0.5.
It's 50%. So 0.5, 0.5. And what's ZC at 99%, guys? You should know that as, again, I keep stressing on this. You should know it by heart. So let me get the calculator. It's 2.575. So it will be 0.5 times 0.5 times, open parentheses, 2.575 divided by the margin of error, which is 0.04. Change it properly, guys, and then square it. Raised to the second power. Okay. And you need to round it up to the nearest whole number. So it will be 1037 as an answer. Even if this is a 0.03, you have to go up, guys. So 1037 is your answer. For the second one, find the minimum sample size needed using a prior study that found that 66% of the respondents said that they support labeling legislation for GMCs. Well, we already know P hat, guys, so it will be 0.66. That's a P hat. Times Q hat. Who can tell me what Q hat is if this is 0.66? It will be what? 1 minus
34.
Yeah, that is correct. Times whatever we put there, guys. Open parentheses, 2.575 divided by 0.04 and then square it. And then your answer should be 930. How do the results from A and B compare? Having an estimate of the proportion raises the minimum. No, having an estimate of the proportion will lower the sample size, so reduces the minimum sample size. As you notice, you had it in the thousands without the prior estimate. We had it 930 with the prior estimate, so it will be part B. I think that's it for chapter 6. And let me tell you guys what I plan to do on